Hello friends, welcome to Blessed Excellence Center of Excellence. We are first class students are groomed and nurtured. Today's video we are looking at Bohr model. Introduction. Bohr model of atomic hydrogen was postulated by Niels Bohr in 1913. He hazarded that electrons travel in specific shell or orbital around the nucleus. The model does not hold for species with more than one electrons. Now let's look at Bohr equation. Bohr equation is given as E equal to 1 over n squared times 13.6 eV, that is electron volt, the unit of energy. Now when two energy levels are involved, the equation becomes delta E equal to 13.6 times 1 over Ni squared minus 1 over Nf squared. This equation can also be expressed as E equal to minus 1 over n squared times 2.179 times 10 exponent minus 18 joules. That is the unit of energy. When two energy levels are involved, the equation becomes delta E equal to 2.179 times 10 exponent minus 18, 1 over Ni squared minus 1 over Nf squared, all in joules, where E is energy of electron, delta E is change in energy of electron, N is energy level of electron, Ni is initial energy level of electron, Nf is final energy level of electron. Other formula associated with the equation is delta E electron is equal to E photon. That means the energy of electron is equal to the energy of photon. C is equal to lambda V. E is equal to HV. And finally, V is equal to C over N, where delta E electron is change in energy of electron, E photon is energy of photon, C is speed of light with a value of 3 times 10 exponent 8 meter per second. Lambda is wavelength in meter, V is frequency in per second, N is refractive index, H is Planck constant with value of 6.626 times 10 exponent minus 34 joules. Unit conversion. When an electron falls from higher energy level to a lower energy level, it emits energy in the form of photon. On the converse, when it moves from lower energy to higher energy level, it absorbs energy. This energy is calculated using Bohr equation as stated above. This energy can be required in joules or in electron volt, hence the need for their conversion. Electron volt EV and joules J are related by the formula 1 electron volt is equal to 1.602 times 10 exponent minus 19. Meter and nanometer are related by the formula 1 meter is equal to 1.0 times 10 exponent minus 9 nanometer. Now let's consider some calculation with respect to Bohr equation. The question is this. It was observed that an electron jumped from energy level of N equal to 2 of hydrogen atom to a higher energy level of N equal to 4. Calculates the wavelength of the photon. Now let's see how to go about the equation, having taken specific notes of the given formula. Now from the equation, we have that our Ni is equal to 2, and then our Nf is equal to 4. Lambda is the wavelength, is unknown. That is what is required of us. We are to calculate for the lambda, so we use question mark to represent it. Then H, Planck constant, has a constant value of 6.626 rather, times 10 exponent minus 34 joules second, while the speed of light has a value of 3 times 10 exponent 8 meter per second. From this equation that delta E is equal to 2.179 times 10 exponent minus 18, open bracket 1 over ni squared minus 1 over nf squared. If you substitute the values, you see, they've given us ni to be 2. So remove this ni and put 2 here. That's how we got this 2 squared. Now, nf is given to be 4. So remove the nf and put the 4. So that's how we got this 4 squared. Now, having substituted that, if you punch 2 squared is 4. 1 divided 4 is 0.25. Then 4 squared is 16. 1 divided 16 is 0.0625. If you subtract 0.25 from 0.0625, you're going to have 0.1875. Okay, now multiply it by 2.179 times 10 exponent minus 18. You're going to have 4.086 times 10 exponent minus 19 joules, and that is the energy of electron. But they are not asking us for energy of electron. They are asking us for the wavelength. So having gotten the energy, we can use it to calculate the wavelength. Now watch this. From the formula that energy is equal to Planck constant times frequency, we also have that speed of light is equal to lambda being wavelength times frequency. Now from this equation now, if we make the frequency the subject of the formula, make V the subject of the formula, you do that by dividing both sides by lambda. You're going to have V is equal to C over lambda. Now substitute this C over lambda in this equation, remove this V and put the whole of this. You're going to have that energy is equal to hc over what? Lambda. So from this now, make lambda the subject. You're going to have that lambda is equal to hc over E. At this point, we substitute by replacing each of the letters with their respective values. So we have that Planck constant in H has a constant value of 6.626 times 10 exponent minus 34 joules seconds. And then the speed of light being C has a value of 3 times 10 exponent 8 meter per second. And then the energy of electron has been calculated to be 4.086 times 10 minus 19 joules. So remove this E and put the value here. If you punch the whole of this, you're going to have 4.865 times 10 exponent minus 7 meter. Now, the second and the per second will cancel out. The joules and the joule here will cancel out, and that gives you meter. That's how the unit is what? Meter. Thanks for watching. This is production of Blessed Excellence Center, BEC. We handle private classes both online and offline. Academic works, we are fully into research and other academics exercises. Thanks for watching. You can reach us on the number 070-437-30069.